Okay, we have our block. We have a crosshair right there so we can drill. What we're drilling for is I want to put a detent right here all around this so I can stop this at the down position every time around. So I'm going to have to drill through this block. My detent mechanism is just going to be very simple. It's going to be a 1/4 inch diameter steel ball and a spring. So when we drill this, what has to be expected is the distance of a 1/4 inch of the depth of the ball, because the ball is going to have to be recessed all the way inside of here so that other piece can slide in. The length of our spring, then we're going to have to drill and tap probably a 1/4 28 set screw to screw into the end of this so I can compress the spring just a little bit to add pressure to the ball. This piece we will probably put into the rotary table at 90 degrees and put just a dot of end of a drill bit every 120 degrees around this thing. First thing I'll have to do is get it set where I want it on the lathe itself. I'll have to put a light punch mark on the side of this so I have a place of reference. This will have to be drilled first and actually put onto the machine before I can put that transfer mark on there. You can't transfer mark it very deep. The transfer punch actually moves material out. It doesn't cut anything, so there'll be a little mound all the way around that mark. It may make this thing very difficult to pull back out once that mark has been made when it's inside. So you have to be very light. Then we'll have a place to start our 120 degree turn to do our dimples. Now this is the thumb wheel that I used to attach to the back side of that spindle that holds the different lengths of stops. So you can see it's knurled, and it has a 50,000ths of an inch shoulder to accommodate the felt washer that'll be soaked with baby oil. So when this piece is inserted, you can see it's flush to the back side. This piece will stand out about 50,000ths of an inch. That's about what it takes to crush that felt. Gives it a nice, good feel, very little in play. In fact, I think it's practically none after it's together. This piece is a 1 inch 650 thousandths in diameter, 680 thousandths thick, minus the shoulder, and it's got a 5/16 hole drilled through the center of it. One thing to remember when you're machining small parts like this where you need both sides, if you have a good way to part it off, then you're okay. But if you have limited means, or your part off tool's not good enough to get through 2 inches of aluminum, or your machine's small, or whatever it is, there's always a way you can help out with that by using a piece of shim stock. So let's say you've got everything done, you've cut it off with a hacksaw or whatever it is that you do, and you need this side nice and smooth and flat just like everything else. You can always take this, flip it over, put it in a piece of shim stock, and put it into the chuck. The jaws will have a very hard time crushing through the shim stock and crushing your part, and still just giving you enough room to do whatever face turning and chamfering that it is that you need to do. Okay, this is the finished product after it's put back together. So you can hear the detent. Now we'll go to the machine. I'll show you how it works. Okay, here we are at the lathe, and I've set the carriage stop to 0 on each position. So there's 0, first position. Zero on the second position. 0 on the third position. So I will reset to 50, 100 thousandths, and 150 thousandths. So start with the 50 thousandths. So there's 0 down to 50. We'll come back up to, we'll pass 0. Rotate. 100 thousandths. And 150. So everything I need to do my little job. I hope you like this episode. Stay tuned for more machining projects yet to come. Thanks for watching.